Hello, my dear students. Today we are moving on to the fifth module, that is planning and learning in AI. So first we are considering planning. For solving an AI problem, we use some basic problem solving strategies, that is control strategies, and represent them using any of the knowledge representation techniques. And we have studied control strategies in second module, and we have learned the knowledge representation technique like uh, first order predicate logic. And in case of complex problems, the representation or the control strategies will not be enough to solve the problem. So in such cases, we can divide them into small sub parts, small sub problems, and then solve those sub problems separately or individually. And now we are going to discuss such methods which is helpful to solve problems by constructing some type of plans. So several methods have been designed for this purpose of decomposition of the problems. They focus on how to divide the problem into appropriate subparts and handle their interactions. So the use of these methods is often called planning. So planning is actually computing several steps of a problem solving procedure before executing any of them. So when we have a look to the problem solving domain of a AI system, for a problem solving, we'll be having a search space, and in the search space, we will have some rules. And how we will move through the search space, moving through the search space is done by using search algorithms. So it's mainly focusing on how the particular task is being achieved. And we'll see it in detail. And here in your syllabus, not in the syllabus actually, planning oriented examples are given by the block world puzzle, because planning it is a type of problem which is being solved by using a planning technique. So that's why the example domain that we are considering this module is completely block world puzzle. So I'll be explaining planning with respect to the block world puzzle terms. Okay, so before moving on to that, we'll just brush up what is a block world puzzle. There is a flat surface and we have some square blocks arranged on it, and all the square blocks are the same size. The square blocks are stacked one upon another or scattered in the table. There is a robot arm to pick up and put down, to stack and unstack the boxes. And moving on to in detail, there are different actions performed on the blocks, and we have some states as well. So the different actions are unstack, stack, pick up and put down. And the states can be on AB, on table A, clear, hold, and I'm empty. On AB means A is the block which has been on B, and on table means A is on the table. Clear A means the top of A is clear, that means no block is on it. Hold A means the robot arm is holding the block A. Arm empty means the robot arm is free, that means it is not holding anything. The next point is to discuss is components of a planning system. There are mainly 5 components for a planning system. For a normal planning system, the first 4 is enough, and that is choose the best rule to apply the chosen rule, detect when the solution is found, and detect dead ends. These 4 are the components of a planning system, which is basic. And in case of complex problem solving systems, in case of complex planning systems, there is an extra point, that is detect when almost correct solution is found. So moving on to the first point, choose the best rule to apply. Consider the cases of AI problems. In every problem, for solving that problem, we will be given with a set of rules. And from those set of rules, we have to pick the best rule to apply next, so that we will be easily leading to the solution. So this is the method of selecting appropriate rules from the list of rules. So the method is that you have to pick or select any one from the list, but if there comes many more than one rules which is having the same priority, what will we do? Which rule is to be selected? In such cases, we will go for a heuristic function, and we will select the rule which is having the most favorable value for the heuristic function. And the second point is apply the chosen rule. That means we are going to apply the rule that is being selected either randomly or by checking the heuristic functions. We are going to apply it, and this application is explained here by using a strips mechanism, that is including 3 different types of lists. One is add, delete, and prerequisites or preconditions. So there are three lists used for that, and I'll explain that with the example of a block wall puzzle. So here we have three different lists using strips mechanism, that is add, delete and precondition for applying the rules, and I'll explain it with respect to the concept of block wall puzzle. And in the case of block wall puzzle, we mainly do have four different types of actions. And the first action is stack. And if we are applying this particular rule, or if we are applying this particular action, what are the contents of these three lists? That is very important. Precondition. From the term itself, it's very clear that what is the data that it is handling or it is having. Precondition is a data structure or a list which is having the statements or the states that is to be achieved before the execution of this action. I'll tell again. Precondition is the data structure which is holding the value or the states that is to be attained for performing this action. That means this contents to be satisfied so that we can do this action. That is a precondition. Add means after execution of this action, the states will be like this. So these add is a data structure which is holding the list of states after the successful execution of this particular action. And what is delete? Delete is that we have to pick from the precondition that after execution, successful execution of this particular action, what all things will come false in the precondition, and that false predicates or false states will be transferred to delete. So we will see it one by one. For stack AB, for stacking block A onto B, what is the precondition that is to be achieved? The precondition that is to be achieved is top of B should be clear and the robot arm should be holding A. That is a precondition that we already have here. And what is the post condition or the true condition which is achieved after the execution of the action stacking? After stacking, A will be on top of B and top of A will be clear and arm will be empty. So there are many different aspects here. So in the successful execution, the robot arm will be empty. It was holding something that will be empty and A will be on top of B. These are two conditions. And now check. After this happens, what all predicates or states in the precondition will go wrong? When A is placed on B, then top of B will not be clear and this become false and we move it to the delete. When arm is empty, hold A has no relevance. Then this particular predicate also goes to delete. Now moving on to unstack. Precondition on AB, clear A, arm empty. These are the preconditions. So A should be on the top of B so that we can unstack it. So after the execution, A will be in the hands of the robot arm. That's why it is called hold A and the B stop will be cleared. Clear B. So what all things are wrong here? After the execution, when arm is holding it, arm empty will go wrong, obviously. When arm is holding A will not be on top of B, so that also go wrong. Clear A will not go wrong because A is in the hands of the robot arm and there is no other block on top of A. That's why we do not have to write clear A here. Likewise, for pick up and put down, we can do this. So this is a type of list for applying rules. Now moving on to the third component of a planning system, that is detecting when a solution is found. That means detect the success. So when the system finds or reaches the goal state, that is success. Okay, and it is achieved by using a sequence of operations or operators. So the detection is very important and it will be easy if we use a best knowledge representation technique. And here we have studied predicate logic, and predicate logic is one of the best knowledge representation techniques so that the system can find whether the goal is achieved, and this searching will be more easy when we represent it in a good manner or standard manner. So predicate logic is a good choice. And the next point or next component is detecting dead ends. Dead ends means the situation when a path will take you into a deadlock and you will never reach to the solution. It is very important to realize the path which is never leading to a good solution, because it is obviously a waste of time. So the same reasoning mechanism that we have used in predicate logic can be implemented here, and in case a path is leading to a state from which the goal state cannot be reached, then immediately we can prune that particular path, because it will always mislead us actually. Okay, it will never lead us to the goal. So for example, if there comes a state robot arm empty and hold X, whether it is true? No, never. Arm empty and hold X will never come together. So if such a situation comes up, that path is wrong, and you can immediately prune it. So that it is very important to detect the dead paths or dead ends. And the last is detecting when almost correct solution is found. So in case of complex problems, it is not actually always possible to reach to the perfect solution. Apart from that, we will go for an almost correct solution. It is discussed like that because in case of complex problems, we are dividing that problem into several sub problems, and we are going to find the solutions for those sub problems, and we are not sure that combining those sub problems will give a perfect solution or not. So we are just assuming something, and we are getting a trial and error. So in the first case, if we assume that they are completely decomposable and we proceed to solve sub-problems separately, then we check combining the sub-solutions and we check whether it yield a correct solution for the problem. And if yes, we can accept it, and if no, we go for another assumption and proceed the same. Actually, it's a waste of time, it's a waste of effort, but in a theory manner, we have to represent the components of a planning system. That's it. Moving on to the next concept in this module, that is goal stack planning. Okay, from the name itself, you can assume that there is a stack in it. Okay, so we are putting the goal into a stack and we are planning for the result. So this is actually sometimes students misunderstand that this is a method for solving block wall puzzle. No, it's not actually a method for solving block wall puzzle. It's actually a method for solving compound goals. If a compound goal means many individual predicates come up or combined using AND. So that can be compound goals, for a complex problem. If you want to find a solution, you can go for the goal stack planning. So this method can be applied on any type of AI problems, and it is best to understand when it is explained by using the example of block wall puzzle. That's why in this module we are using block wall puzzle as an example. But don't write that it is a method for solving block wall puzzle. It's actually one of the earliest technique for solving problems which involve planning. That means for solving the compound goals. So it's an approach used by the strips mechanism of problem solving. In goal stack planning, we use the data structure stack for problem solving purpose. So I'll show you the example first. After that, we will move on to these concepts. The first thing that you are going to do is you have to always remember, or you have to be always ready with the precondition rules, because this is a hero and we need this throughout the solution. So it is very important to remember the precondition rules of block wall puzzle, and here we are demonstrating goal stack planning method by using the example of block wall puzzle. It is not a mechanism for solving block wall puzzle. It's a mechanism for solving compound goals. It's a planning method, and we are showing goal stack planning with the help of block wall puzzle. Okay, so see the question here. This is an example. This is the initial state and this is the final state. Here we have a set of states for the initial state. Okay, initial state in the set of states ഞാൻ ഇവിടെ എഴുതിയിട്ടുണ്ട്, and goal state ന്റെയും set of states ഞാൻ ഇവിടെ എഴുതിയിട്ടുണ്ട്. No matter നിങ്ങളിവിടെ ആം എം ടി ക്ലിയർ സി ക്ലിയർ ബി ആ മൂന്നെണ്ണം എഴുതിയാലും ഇല്ലെങ്കിലും ഒരേ എഫക്റ്റ് ആണ്. ഈ നാലെണ്ണം വന്നാൽ തന്നെ നമ്മുടെ റിസൾട്ട് ആയി എന്നുള്ളത് കൊണ്ട് ഞാനത് മിസ് ചെയ്തതേ ഉള്ളൂ. എഴുതിയാലും ഇല്ലെങ്കിലും ഇറ്റ് ഹാസ് എ സെയിം എഫക്റ്റ്. അത് ചെയ്ത് വരുമ്പോൾ നിങ്ങൾക്ക് ക്ലിയർ ആയിക്കോളും. So the first thing that you are going to do is we are starting with what? We are starting with the goal. So first you have to combine the goal states by using AND symbol. So goal state la 4 states ആണ് ഇവിടെ എഴുതിയിരിക്കുന്നത്. അതിനെ AND symbol വെച്ച് കണക്ട് ചെയ്ത് നിങ്ങളൊരു compound goal create ചെയ്യണം. This is a compound goal, and this compound goal can be divided or separated into 4 different subparts. on C A, on B D, on table A and on table D. So we'll see how it is being solved, and you have to consider the left side as a database, and this database will show you the changes happening when this particular condition is or any action occurs here. If any action occurs here, this shows you the change here. So this is a database for the change, showing the change in the state. And here we have the stack. This is a stack, okay, and here we have the stack, and we have written the goals here first. The goal state is written here, and we have subdivided the goal state and we have entered it into, this was a compound goal, and that's why we have subdivided it into different parts and we have entered into a stack, and the arrow mark shows you top of the stack. Hope it's clear to you. And first I am checking whether on table D, okay, whether the content on the top is true or false in the existing situation. So we are comparing the goal state with the existing state or an initial state. So if the condition that we are checking is true, okay, already true ആണ് എങ്കിൽ നമുക്ക് വേറെ ഒന്നും ചെയ്യാനില്ല, നമ്മൾ അടുത്ത condition check ചെയ്തു പോകും. So the top of the stack is a satisfied goal here because on table D correct ആണ്. D table ടോപ്പിൽ തന്നെയാണ് ഇരിക്കുന്നത്. ഇവിടെ എഴുതിയിട്ടുണ്ട് on table D. That's why pop the content. On table D എന്നുള്ള കണ്ടന്റിന് ഞാൻ എൻ്റെ സ്റ്റാക്കിൽ നിന്ന് പോപ്പ് ചെയ്യുന്നു. ആൻഡ് സ്റ്റാക്കിൻ്റെ ടോപ്പ് എവിടേക്ക് പോയിന്റ് ചെയ്യുന്നു? ഓൺ ടേബിൾ എയിലേക്ക് പോയിന്റ് ചെയ്യുന്നു. സോ ഓൺ ടേബിൾ A true ആണോ എന്ന് നോക്കുക. Whether it is true in this case, on table A is on the table, right? On table A, here it is given on table A is true. That's why pop on table A, and I'm moving on to on BD, and I'm checking whether B is on top of D. Whether B is on top of D, this is not a satisfied goal, this is an unsatisfied goal. In case the stack top or the top of the stack is pointing to an unsatisfied goal, we have to mention the action which is to be performed to achieve that goal. അതായത് on BD എന്നാണ് നമ്മുടെ ഇതിനകത്ത് തന്നിരിക്കുന്നത്. on BD ആവണമെങ്കിൽ that means B should be on top of D. B ഇപ്പോൾ ഡിയുടെ ടോപ്പിലല്ല. If B is to be on top of D, what is the action that we have to do? നമ്മുടെ ലോജിക്കൽ ഐഡിയയിൽ ചിന്തിക്കുമ്പം ഇവിടെ നമ്മൾ നോക്കുകയാണെങ്കിൽ ഡിയുടെ ടോപ്പിലേക്ക് ബീനെ കൊണ്ടുവരണമെങ്കിൽ ആദ്യം ബീനെ ഇവിടെ നിന്ന് അൺസ്റ്റാക്ക് ചെയ്യണം. ആ രീതിയല്ല പറയുന്നത്. ബി എന്നുള്ളത് ഡിയുടെ ടോപ്പിൽ വരുന്ന ആക്ഷൻ, അതിന് എന്ത് പേരാണ് പറയാ? വി മെൻഷൻ ഇറ്റ് ആസ് സ്റ്റാക്ക് ബി ഡി. സോ ഓൺ ബി ഡി കറക്റ്റ് ആവണമെങ്കിൽ എന്ത് ചെയ്തിരിക്കണം? Stack BD ചെയ്തിരിക്കണം. And you have to write the preconditions for that action stack BD here. For stacking B on D, arm should be holding B and D should be clear. And you just enter those two preconditions to the stack, and the top will be pointing to the top value here. It is clear D. I am checking whether D is clear. Whether D is clear? Yes, D is clear. That's why I'm moving on to the next. The top is pointing to hold B. Whether the robot arm is holding B now? No, it's empty. Arm is empty. So that's why what we have to do, the next action for holding B means B is now on the top of A. So for holding B, we have to what? Pick up or unstack. We have to unstack it. Okay. So the action performed is unstack BA. And what are the preconditions for unstacking B from A? Arm should be empty, B should be on top of A, and top of B should be clear. And we have to enter those values, enter those preconditions to the queue, not the queue, to the stack. And the top value will be pointing to clear B. Whether clear B is true? Yes, B is clear. Clear B is given here. And next it is pointing to on BA. On BA, it is given here. On BA is true. So that is popped. Arm empty. Whether arm is empty? Yes, arm empty is given here. So that's also true. When all the conditions in this state gets true, we can execute that action and come back to the stack. So when we execute that action, what happened here? See, unstack BA. B is now in the robot arm's hands. So the state changed to hold B. On table A, on table C, on table D, clear A, clear C, and clear D. So this is a state now. And now what we are going to do is, now the checking onto the top value, that is hold B, whether hold B is true or false. Hold B is true because arm is having B. It's written here hold B is true. That's why this particular conditions are satisfied and we can perform stack BD. What happened here? So the database changed and we have stacked B on top of D. And what comes next? On BD. On BD is satisfied now. So we have popped it and we have gone to on CA. Whether C is on A? No. So what should we do for getting C on A? The process of keeping C on A is called stacking, stack CA. So what are the preconditions? For stacking C on A, the arm should contain C and A stop should be clear. So insert it into the stack. We are holding C, we are clear and A is clear. So we are checking the top value. Clear A is true. Okay, but hold C is not true. Why? C is here and arm is empty. For holding C, what the arm should do is pick up C. So write the preconditions here and I am inserting the preconditions to the stack. Okay, and checking the top value. Clear C, whether C is clear? Yes, C is clear. On table C, yes, on table C is true, so pop it. Arm empty, arm is empty, so pop it. So all the conditions satisfied, I am doing the next action, that is pick up C. So now pick up C have done. So C is on the hand of the robot arm. So hold C comes true. Okay. So this particular condition got correct and I have executed the stack CA action. See. So now the value on the top is on CA. Whether it is true or false. On CA get true. So that's why I'm popping it. And I have combined the solutions together so that I've got the result as the given goal achieved. So what is the order of the actions? Unstack BA, stack BD, pick up C and stack CA. The procedure is done. This is what is called goal stack planning. And now this is the okay. This is the algorithm for goal stack planning. So first we push the goal to the stack, and if it is a compound goal, then we have splitted it and again pushed it. And if it is a single unsatisfied goal, what we have done? We have taken the corresponding action and we have inserted the preconditions of that action to the stack. Okay, then replace it with an action, push the action preconditions to the stack. Alright, and if it is an action, what we have to check? Whether it is preconditions are satisfied or not, and if all the preconditions are satisfied, then pop it and execute the action and make changes in the block state. We have changed it in the left side. That means we have changed the database. And if the stack top is a satisfied goal, if it is true, what we have to do? We have to pop it from the stack, and this is the algorithm. That's why in the explanation is given that the goal stack planning concept contain goals, operators, add, delete, prerequisites. Okay, we are using all of these, and a database maintaining the current situation. Okay, this all together comes up as goal stack planning. Hope you understand the concept. Okay, so this is the most frequently asked question, essay question actually, goal stack planning. So it's very important. You have to write the steps, you have to write the preconditions list, you have to then work out it and show the state changes. Okay.